All right, so in this lesson, I'm going to be discussing percent yield. And percent yield basically tells you how effective your laboratory technique is. There are two major concepts around percent yield, your theoretical yield and your actual yield. Your theoretical yield is what you calculate should form, the amount of product that should form based on how much reactant you start with, while your actual yield is what you actually collected in the lab. Okay? So in this problem, it first asks me to write my balanced equation. So it tells me I've got calcium hydroxide. So calcium has a 2 plus charge. Hydroxide has a 1 minus charge. Okay, so I got to cross my charges, and I end up getting CaOH2. Okay, and my other reactant is hydrochloric acid, and they give me the formula for that. So this is going to be a double replacement reaction, innies and outies. Calcium is going to form a new compound with chlorine. Okay, so when I cross my charges, I get CaCl2. And then hydrogen and hydroxide are going to combine together. Hydrogen's +1, hydroxide's -1. And so that gives me HOH, which can just be written as H2O. So this is a neutralization double replacement reaction. I just now need to balance. I've got 2 chlorines on my product side, 1 on my reactant side, so I'm going to put a 2 in front of HCl. Now I've got 2 hydrogens from CaOH2, 2 from hydrochloric acid, so that's a total of 4. So I'm going to put a 2 in front of water, okay, and I am balanced. Next, it tells me if I have 2.20 grams of calcium hydroxide and 1.50 grams of hydrochloric acid, what is the limiting reactant and what is the excess reactant? So I want to figure out how much product is formed. I'm going to go down and I'm going to cheat a tiny bit. It tells me that it wants to know how many grams of calcium chloride will precipitate. So I'm going to take both of these quantities of my reactants and I'm going to convert them into grams of my product. Okay, so I'm going to take that many grams of CaOH2 and I'm going to get that into grams of calcium chloride. And then I'm going to do the same thing for the hydrochloric acid, 1.50 grams of hydrochloric acid, and I'm going to convert that into grams of calcium chloride. Okay, so first I need to get out of grams of each of these. So out of grams of calcium hydroxide. Okay, I first need to get into moles of calcium hydroxide. Once I'm in moles of calcium hydroxide, I can then easily get into moles of calcium chloride. Now I can get into grams of calcium chloride. Okay, I'm going to do the exact same thing, but now for the hydrochloric acid. Okay, so I'm going to get out of grams of hydrochloric acid into moles of hydrochloric acid. Okay, then out of moles of hydrochloric acid into moles of calcium chloride now. Okay, then out of moles of calcium chloride and into grams of calcium chloride. All right, so let's plug in our conversion factors. So for calcium hydroxide to go from grams to moles, I need to determine the molar mass of calcium hydroxide. So for calcium, its molar mass is 40.078. Oxygen is 15.999 times 2, because I have 2 oxygens, plus hydrogen, 1.008 times 2, because I have 2 hydrogens. So for every 1 mole of calcium hydroxide, I have 74.092 grams of calcium hydroxide. Okay. Then for the mole to mole ratio, the coefficient in front of calcium chloride is a 1, in front of calcium hydroxide is a 1, okay? And then I need to determine the molar mass of calcium chloride. So calcium has a molar mass of 40.078, chloride is 35.453, and I need to multiply that by 2, okay? So the molar mass I get is 110.984. Then I need to do the same thing, but for hydrochloric acid. So hydrochloric acid, the molar mass 1.008 plus 35.453. I get a molar mass of 36.461. grams for every 1 mole. Mole-to-mole ratio here, there's a coefficient 1 in front of calcium chloride, a 2 in front of hydrochloric acid, and then I already got the molar mass of calcium chloride. It was 110.984 grams for every 1 mole. Okay? So when I actually do out the calculations, 2.2 divided by 74.092 times 1, so nothing, times 110.984, and keep in mind this is for every 1 mole of calcium chloride. Okay. If I round to 3 sig figs, which I need to do because that's the fewest number of sig figs in this problem, I get, so unrounded, it was 3.295, so this would then round to 3.30 grams. Okay. Meanwhile, so that's how much calcium hydroxide produces. Calcium hydroxide produces 3.30 grams of calcium chloride. For hydrochloric acid, 1.5 divided by the molar mass, 36.461, divided by 2 times the molar mass of calcium chloride, 2.28 grams. Okay, so this question asks what is my excess and what is my limiting reactant? Well, since hydrochloric acid produces less product, it is going to run out first. So that is my limiting reactant, while calcium hydroxide is my excess reactant. Okay. Meanwhile, it says how many grams of calcium chloride precipitate can be formed. Well, which of these two amounts is actually formed? That's 2.28. Okay, so terminology time. This 2.28, the amount of product that should have been formed, that is my theoretical yield. How much product, based on the amount of reactant I started with, theoretically should have formed. To determine my percent yield, your percent yield is simply your actual yields, how much actually formed, divided by how much theoretically should have formed. Okay, so this problem tells me my actual yield is 1.22 grams. My theoretical yield is 2.28 grams. I'm then going to multiply by 100%. And I want to round to 3 significant figures because both of those values have 3 sig figs. So I get, once I round, 53.5% as my percent yields. Okay, so it's very possible I might have lost some of the calcium chloride when I was transferring it, which would explain why my percent yield is below 100%.